This lecture will cover Chapter 3 of the Murox JavaScript and jQuery 4th edition text. And this chapter will cover the essential JavaScript statements, those being a deeper dive into conditions and loops. So our goal this chapter is to take what we've learned so far and code, test, and debug a specific application. What we'll be learning is how to describe the rules for evaluating a conditional expression or an if statement that consists of relational operators, including the use of the isNaN method, which stands for is not a number. We'll also describe the use of logical operators and the rules for evaluating a compound conditional expression, including order of precedence and the use of parentheses. An example of this might be if something is equal to something else. We'll also describe the flow of control for an if statement that has both else if and else clauses. We'll describe two ways that you can code a conditional expression that tests with whether a Boolean variable is true or false. We'll describe the flow of control for three different loops: the while loop, the do-while loop, and the for loop. We'll also describe the use of a JavaScript array or list, including the use of indexes in order to access elements of that array or list, and the length property of an array, which describes how many members there are in that list. Lastly, we'll describe the use of a for in, and a for of loop for processing each element in an array. So here are our relational operators. We've got the standard double equals, which means is equal to. Now, I always think of the number of equal signs here. Now, equal to with two equals will compare two different things, or two of the same things, but it compares by equality, not by type. So if I had a string of 1 and the number 1, the string in quotes, and the numeral 1, and I tested that, they would be equal to each other. If I were to add a third equal sign to that top operator, that would be the equal to plus the type, and then a string would not be equal to a number. The exclamation point you see in the second operator means not. It means it in every programming language. So what we're seeing there is not equal to. And again, you could add a second equal there, and it would test not only equality but type as well. The greater than is pretty common, and so is the less than. Most of you should be familiar with that just from math. Then we have the greater than or equal to. So greater than with an equal sign and less than with an equal sign. These are our relational operators as they test relationships between two elements. So here are some examples. We've got last name equals Hopper, a string, and test score equals 10. So we're saying, is last name equal to Hopper? Is test score equal to 10? So by using the double equals, we're testing the condition. Are they equal? Well, if we write an if statement before that, we'll have that. Now, first name not equal to Grace and months not equal to 0, that's also a conditional expression, but showing that something is not equal to something. Then we have our greater than or less than, a greater than or equal to with distance is greater than or equal to the limit, and stock is less than or equal to the reorder point. Lastly, we have a rate divided by 100, which is greater than or equal to 0.1. So these are all conditional expressions that are going to make a heck of a lot more sense when we get them in the with the actual if statement. So the next thing we need to focus on is isNaN. That stands for is not a number. So what we can do is write isNaN for a string like Hopper, and it's false. However, if we do isNaN for 123.45, it returns false, because that is actually a number regardless of the fact that it's in quotes. Regardless of the fact that that's in a string, it's going to test that is not a number will not be false, because it is true. Now these are our logical operators, and they're used for compound conditionals. So if we're testing one value and then another value and both have to be true, we would use something like and. So if Chris, me, is greater than 40 years old, and also Chris, me, is less than 60, then it would return a true expression. So the double AND, or it's called the AND operator, returns a true value if both expressions are true. This operator only evaluates the second expression if it is necessary. So we don't see that a lot. Usually when we have it, it is necessary to have both. So we're saying that both need to be true. The double pipes in the second operator is an OR. And this returns a true value if either one of them are true. If Chris is greater than 40 or Chris is less than 60, that would return true as well. The operator only evaluates also the second expression if necessary. And once again, we see the exclamation point, which always equals not. And that reverses the value of the Boolean expression. Not equal to. Not is NaN. Not is not a number, which means is a number. So here's some examples of conditional expressions with logical operators. In example 1, we have the AND operator. So if age is greater than 17, and also, and notice how I'm using the words and also, I use that for the two ampersands, the two and symbols, because I want to make it sound like it makes sense in English. So if age is greater than 17, and also the score is less than 70, then do something. Example 2 uses the OR. If the rate is not a number, isNaN, or the rate is less than 0, then we have a problem. Lastly, example 3, the NOT operator, is not a number age. So if the age is not a number, but it's not is not a number, then it is a number. So it's basically negating itself. It's saying this is a number. So the order of precedence for the logical operators starts with the no, that's first, and then the and then the or. So here's some terms that you need to digest a little bit. A conditional expression, which is simply an if statement that tests something. It's a condition. Something will occur if something does something. Relational operators, which we just discussed. Compound conditional expressions, where we have if something equals something and also something equals something else, or not. The logical operator, the order of precedence, and the short circuit operator, which is shorthand. So here's the syntax of our if statement. This is where it all comes together and starts to make sense. If condition 1, then let's do statements. It could be something like, if the language setting on the browser is English, then greet the user in English. Then we have an else if, condition 2 statements, and else is the last statement. So you can have as many else ifs as you need, but they always end with an else. And notice that the else statement does not have parentheses. It only has curly braces. So that is sort of the filter at the end of the if statement. Also, we have an if statement with an else clause. If age is greater than 18, alert you may vote. Otherwise, alert you are not old enough to vote. So this is an if statement with else if and else clauses. If the rate is not a number, isNaN, alert you did not provide a number for the rate. Otherwise, if the rate is less than 0, the rate may not be less than 0. Otherwise, if the rate is greater than 12, the rate may not be greater than 12. Lastly, after all those filters go through, the first if, else if, then we have a condition where the rate is okay, in which case we can alert the user and tell them what the rate is. Now, an if statement with a compound conditional would need either an or an and. So in this case, we have if, hypothetically, a user entry is not a number, or it's less than 0, we can alert enter a valid number greater than 0. Now, this is compound because it has two different things that need to be met. Is not a number, or is user entry less than 0. So it has two conditions. Actually, because it's an or, only one of them needs to be met. But this is a very common expression. Now, a Boolean value, just to review from chapter 2, is it true or a false? It's a variable that can only be true or false. So what we can do is test to see if something is true. So if is valid is equal to true, then do something. I can also test just if is valid. Now this is important. So this is why in a lot of code you will not see is valid is equal to true, because we just test its existence by writing if is valid. However, to test that if it's false, we can write if is valid is equal to false. Or if no is valid is equal to true, because not is valid being true would mean that it's false. Or we could do not is valid, which is the same as not is valid is true. Now with Booleans, I would like to reiterate that a triple equal is a little bit more appropriate because it tests not only equality but type. On to while loops. Now the syntax of a while loop is simply while, the condition in parentheses, and then the statement. So here we have let sum equals 0, let I equals 1. Well, I is less than or equal to 5. Let's take the variable sum and continually add I. Lastly, we increment the I. And then finally, we alert the sum. So what's happening here, first of all, is we're using let as a variable declaration because in constructs like loops or conditions, when you assign a variable using let, when you declare a variable, what will happen is when that construct is over, the browser will release the memory. So it's a lot faster than using var, which is used for global scope. So we often use let to declare our variables in while loops or in any loop. So what's happening here that may be new to you folks is that plus equals inside the while loop. That is what's called a concatenation operator, and it's continually adding I to sum. So sum's going to retain its value. So what happens here is on the first turn of the loop, sum would equal 1. Then on the second turn, sum would equal 1 plus 2, which is 3. On the third turn of the loop, it would be 3 plus 3, which is 6. On the fourth turn, it would be 6 plus 4, 10, and on the fourth turn, it would be 10 plus 5, which is 15. This is a very common occurrence when we want to add money or something like that over time. Now, a while loop that makes sure a user enters a positive number can be done simply by using the prompt. So in this case, I'm using prompt with enter number of years, and I'm using parseInt to make it an integer. I'm using it as parseInt because we can't perform mathematical expressions on strings. So if it gets entered, I want to make sure that my program knows that it's an integer. If it weren't an integer, if it were a decimal, you could use parseFloat. So I'm saying let years equal whatever the number of years that gets entered, but in number format. Now, the while loop has a compound expression in it. It says, okay, as long as isNaN years, in other words, as long as years is not a number, or if years is less than 0, we know there's a problem. So we can make a variable that equals years, that equals prompt. Years must be a valid positive number, which is what is going to be showing again. So we're basically doing an error message using the window object. Now this is a little bit different. This is a syntax of a do-while loop. And what that does is it does something as long as a condition holds true. So in this case, I have let years equals null. So basically, years is going to be equal to nothing at first. And then I can perform the do, where years must be parseInt number of years. And you can see the concatenation with the carriage return, the \n. So if you had missed this prior, \n is a carriage return. And what we're doing is prompting enter number of years, and then a break, and then must be valid positive number. So whatever gets entered there is going to be a number. And so as long as the years is not a number or the years is less than 0, then we can do that section. So basically we're doing something before those values. So it makes sure that a user enters a positive number now because you're doing something before the condition is happening. On to the for loop, and I have examples of all of these inside the module folder, but let's focus on the syntax of a for statement. So a for loop that adds the numbers from 1 through 5. In this case, I let the sum equals 0, which is called a counter initialization. That is what we start our loop with. Our second parameter, and they're parameters in the for loop because they have semicolons, is going to be the condition. So we're saying we're going to have our loop start at 1, and as long as I is less than or equal to 5, we're going to continue looping. The last is the increment expression. So what you see there is plus plus, which means I plus 1. So on each turn of the loop, we're going to have sum that equals 1, 2, 3, 4, 5, where I is. But much like the while loop in the previous slide, it's continually concatenating. So on the first turn of the loop, which is 1, sum equals 1. On the second turn, sum will equal 1 plus I, which is 2, or 3. So 3 is the sum. On the third turn, it's 3 plus 3, which is 6. On the fourth turn, it's 6 plus 4, which is 10. On the fifth turn, I is finally equal to 5, and 10 plus 5 equals 15. So you would display that as 15. It's recommended when you see these small constructs that you type them and test them. You can even type them inside the JavaScript console, the developer tools on Chrome, and you can see the results. In fact, let me do that for you. I'm going to go to my Chrome here, and I'll just open up a new tab. And what I'm going to do is show you how to test this stuff, just for kicks. So let's say I have the console, right? And I can remove all my expressions. I can actually clear this console as well. But right here, I can actually put my cursor. And I can do for let I equals 1. As long as I is less than or equal to 5, which is the condition, I plus plus, like this. Sometimes I get a little tired of PowerPoint, and what I want to do is do sum plus equals I. And then down here below, I can alert, I can always declare sum before this. So I'm going to copy this, and we're going to kill off this, and I'm just going to do it, we'll do let sum equals 0. And then I'll do that because sum would have the value. And then when I hit enter, you see 15 there. So that is a way you can test the code live on your developer tools. Now back to this lecture. Yeah, so the for loop, I want you to get really used to that plus equals. And those are concatenation operators, but you can have a decremental operation as well. You can do minus equals. You could change that for loop and start it at 100, and as long as it's greater than or equal to 1, you can have a reduction. But we'll go through that inside the course materials. Okay, so this is now getting a little bit more complicated. Let's try a for loop that calculates the future value of investment. And this is inside your text. So we have a constant, which means the variable is never changing. Constant equals $10,000. Now, that is, again, non-changing. That's why we're not using var to declare that variable. But our other constants are the rate of return, 7, and the number of years of our investment. So what I'm doing is creating a variable called future value that equals the investment, which is 10,000. And now I'm looping around the number of years that I have invested, in this case 10, and I'm concatenating the future value times the annual rate divided by 100. So it's basically the future value starts at 10,000, and on each turn of the loop, we're going to multiply it by 7 divided by 100, which means 7%, 0.07. And we're going to do that for 10 years, and now we'll get our total. So if I invest something with $10,000 right now, for 10 years at 7%, it's going to be $19,672 in 10 years. Now, it's important you focus on that top level, but other ways that this could be coded is simply by using future value equals future value plus. That's the same thing as the concatenation. So both of those are ways of determining the percentage and the investment value over time. Okay, so far we've been using a for loop with plus plus. In the top loop up here, we're looping to 10, but we're going by 2's. We do this by doing plus equals 2. Remember, the third parameter of a for loop is the amount of incremental, the amount that I changes, the variable I changes as you loop. So in this case, we start at 0, we add 2 to the itself, which is I, plus equals, and then we do 4, 6, 8, 10. And the second loop there decrements. So we started at a higher number, and as long as it's greater than 0, we can decrement by 1. So this says 3, 2, 1, and blast off. Pretty simple stuff, but we really need to learn these basics before we move on. Now this application is the miles per gallon application from your text. And this is a prompt for it. So the page says repeat entries yes or no. The MPG application in the browser has two different calculations here. So let's talk about how it works. In this case, we have the body element of the miles per gallon application. And this is done with a do while loop. Now, you could still do this without a do while loop. I want to make very clear about this, okay? So what do we have? We have a do, and we have constant miles equals enter the miles driven. So you can visualize this. There's a prompt box that will pop up with the message enter miles driven. You're going to enter your miles. Then you're going to have a constant with gallons that enters gallon of gas used. So we have two variables from the user entries. If the miles is greater than 0 and the gallons are greater than 0, let's figure out the miles per gallon. We have constants of MPG. Now, that second line where it says const HTML, and you see the backticks and the $ with the curly braces, that is shorthand for variables. So what we're doing is putting a sentence together, a string of HTML, and the backticks tell JavaScript to look for the $ and anything in curly braces as a variable. So that would be whatever I entered for miles, and then on $ curly brace gallons, that's also a variable. Now, one very important thing that you're going to use a lot is that to fixed parentheses 2. That formats any decimal to two places. So if MPG in this case were 20.685, then it would be 20.68, and it rounds up from 5, by the way. So after 5. So otherwise, we alert one or both entries are invalid. And then now we have a variable again, which means repeat entries, and well again equals y. We do it again and again and again. Okay, so this is how to keep it moving over and over again. This is the first of 3 prompt dialog boxes. So in this case, we're going to have enter your investment and then calculate that investment. So in this case, we're doing another do while loop that starts with let investment be equal to 0, and then we do the investment equals whatever gets entered. Now notice on the 4th line there where it says prompt enter investment amount as xxx point xx, and then a comma. Well, what comes after that is the placeholder of what would be inside the prompt. The things in quotes go in the box, but this is actually inside the prompt field where the user enters the total. So then we have our while loop. As long as it's NaN, as long as investment is not a number, let the rate be 0, and do another prompt box. So let rate equals 0, do, as long as is not a number rate equals parse float prompt, enter that. And in this case, the placeholder is 7.5. And lastly, we do the year. So basically, we're looping around investment, the interest rate, and the number of years for our investment application. Now, for the display, this is done in for loop. So what we're doing is now looping again. This is the same code that we saw before from a few slides ago, and we're document writing the investment. Now this is going to show an average. So in this case, we're going to enter test scores. And as soon as we enter -1, we'll know that it's the end of the scores. So what we're going to want to do is keep the value of the entries so that we can add them and divide by the number of entries. So let's talk about how it works. By using a do while loop, we can make this function. So I'm using let total equals 0, count, score. All of these start at 0. First thing we do is get the score from the prompt. So you see score equals parse int, prompt enter test score, or enter -1 to end scores. And -1 is by default in the text field in the prompt box. So if score is greater than 0 and score is less than 100, let's add it. That means we're good, less than or equal to 100. Because you can get a 0 and 100. And this is a compound conditional expression. So we're doing total equals total plus score. We could also do total equals plus equals score. And then we count, we add 1 count. So the count is how we're going to figure out how many scores there are. Then we write score, whatever the count is, in the score. Else if the score does not equal -1, that means the score must be a valid number because it didn't match the first condition. So in this case, we have an if and an else if. As long as the score is not equal to -1, what we can do is create the average. So the average equals parseInt total over count, meaning parseInt's going to turn into a number, and then we can write that number. Okay, so let's move on to arrays. Now we're going to be going into arrays in much deeper detail in the coming weeks, but it's how JavaScript stores data as lists. So this is a very common thing. It needs to be learned if we're going to be functional with JavaScript. So what we can do is create an array just by using the array constructor. And that means we have a variable. Now with arrays, if they're fixed, you're going to use constant because they're not going to change. But array name equals new array length. Now if array name does change, you can use a different type of declaration. So you have two choices. You can create new array and then put a number in for the length you plan for the array. If I don't really fix the number because I like to change my arrays, but you could have an empty parenthesis, new array, empty parenthesis, and it would still create a variable that equals an array. You can also use an array literal, meaning you have blocks that hold the length of the array. So basically, the statement that creates an array, the simplest way to do it is do what I show here. Const totals equals block. So the syntax for referring to an element of an array would be the array name and then whatever the index is. So index will be a number, and arrays are zero based. So the first element of an array is going to be 0. So totals block 2 block would be the third element of an array. Totals block 1 block would be the second element of an array. Totals block 0 block would be the first member of an array. So here we go. I've declared an array here called totals, and the first one is 141.95, the second is 212.25, the third is 411. So we've created a totals of individual statements. We don't see this too often. What we usually see is a single statement like you see at the bottom. Const totals equals 141.95, 212.25, and 411. So we can use the length property to get the number of elements in an array. So in this case, I have constant count equals totals.length. So it's not zero based, it's actually the actual number of elements in an array. So how do we add the value to the end of the array? We can do totals length equals 135.75. Because if the total length is the total number, that means that we've added an element to the end of the array, because the length itself would be one more than the zero-based index. So if you think about the totals, last time it was 0, 1, 2. Those were the indices. Totals length would be 3, so it's basically totals 3 equals 135. That's because arrays start at 0. So this is an example of code that will put numbers 1 through 10 into an array. I've declared an array called numbers, and now I'm looping from 0 to 9 because we're going I less than 10. And I'm putting the I as the index of the numbers array and adding 1 to I every single time. I could always do I plus equals 1 as well, and that would work, but it's already incremented, so we could just keep it like this. And what's happening is the numbers now would have an array from 1 to 10. So that also, it's something to consider, the fact that let I equals 0, it's going to be 1 initially. The increment doesn't happen after, it happens before. And the last thing on this page is the code that displays the numbers in an array. So I've got a display string that's empty, and I'm looping through the numbers. Notice that the second parameter of the for loop, the condition, that says as long as I is less than the numbers dot length. So as long as it's less than, we'll keep looping. But once it's less than, once it's equal to, we have to stop looping. So we're doing display string plus equals because the string is being concatenated to. We're adding the numbers to this string. And then we have a space in between, which is why we have displays 1 through 10. In this slide, we're going to put 4 totals into an array. We've got totals as a literal, and we have 0, 1, 2, 3 with numbers. Lastly, let's go ahead and sum all those totals. So I'm letting sum start at 0, I'm declaring it as a number, and I'm looping once again through the length of the totals, which in this case will be 4. So as long as I is less than 4, I will be, hit 3, which means that last sum will be 135.75, but we're going to continually concatenating to the sum. So now, in this slide, we're going to finish up with our totals, and we have code that displays the totals and the sum. So we're going to use a total string, again, just like we totaled the number, and again, we're using that \n, which is a carriage return. You'll be using straight HTML mostly for this kind of thing, but in a prompt box or something like that, we don't have the ability to put HTML. We have the ability to put carriage returns. But in this case, we have the totals are the string itself, which was concatenated with the totals, and that's why we have the sum. All right, this now is the syntax of the for in loop. So a for in loop will do totaling of the numbers in an array. It's just a different type of loop. I would say get really familiar with for in because we use it also to loop through objects. But all of these loops will need to be understood because you'll see them all over the place. But I'm saying for, as long as I is in totals, let's sum the totals. So the for in breaks apart an array. It breaks apart our totals array into indices because each turn of that loop, I will be each index. And that's why at the top it says index initialization in array statements. Now let's do a for of loop. So this is the same code that totals numbers in an array, but with a for of loop. In this case, we'll do for let val of totals, then the sum will plus and equals the value. So it's very different because val holds the current value. If I go back, you'll see I holds the current index. Very different. So as a mnemonic device or a way to remembering, for in is for indices. For of is for holding current values. Most of the time you're just going to do this so much that it's going to be inherent. So don't think like if you don't understand it yet. The idea is to use it to solve something and then you'll feel comfortable. So these are the terms we just went over. Arrays are lists. An element is one part of an array, one member of that list. The length of an array is the total number of members in that list. An index of an array is a way to access individual elements of an array. So we use 0 as the first element of an array, then 1, then 2, then 3. Our for in statement will be looping, but using indices in arrays. And our for in loop demonstrated that. Then we used a for of statement, which used the value, which kept the value of each element of the array. And then we did a for of loop demonstrating that as well. So this is the result of our test scores application, which utilizes all of these things. So I have the JavaScript for the enhanced test scores right here. We have a constant. We're declaring the scores to be a variable, an array. And then a do while loop. So what we're doing is saying enter a test score or enter -1 to end the scores and showing -1 as a placeholder. Now if the scores are greater than 0 or less than 0, we can add that to the score. So we're adding to the length of the array and making the new value equal to that new member of the array. And as long as the score is not equal to -1, we are not totaling anything. So that's our while loop. Now, if the scores.length is greater than 0, let's loop through those. Let's find the total, and let's output it. So we have score, which is I plus 1, so 1, 2, 3, 4, because we started at 0. And then we have that specific score. And lastly, we can find the average by parsenting the total divided by the total number, which is represented by scores.length. So that is the way we can do these two mini applications. It's a lot to digest, but we'll be going into far more depth throughout the course in loops, conditions, etc. Just follow my videos that actually show the actual code. Take the code, download it, play with it. You guys should all be fine.